button. You just
Okay.
Here we go. You got it. Thanks for that, Murray. Thanks very much. Just to also let you know, it came through fairly late from BICSI head office that this webinar does have 2 CECs attached to it. So apologies for not getting this information to you sooner. We were hoping to get it earlier, but it's just been a bit of a juggle to do that. So we're pleased to say that we do have 2 CECs. Importantly, for those of you who are credential holders, I know it's been a long, hard run to try and collect. Thanks for that, Len. I got the thumbs up. That's great. And for those that aren't able to make it today, it will be recorded so that people will be able to access it. And we have had confirmation that it will be, watching the recording will attract the 2 CECs, which is very important. If I can just introduce our speakers, as many of you know, Murray Teale, the chair of the Australian Standards Committee, CT1, as well as the regulatory framework. Murray, you can let everyone know your background a little bit. Murray's is also the Director of VTI Services, been involved with BICSI for many years, providing leadership and direction in terms of standards. We planned this presentation many months ago, but there's been a recent ISO meeting that has some significant changes introduced, and Murray has very kindly attended that meeting, very kindly agreed for his presentation until now. We also have Peter Turnbull, who's the Director of P2C Engineering. He's going to talk to us about risk after Murray's presentation. The two work very much hand in hand because at the end of the day, standards are our best friend in terms of protecting us from various things, making sure that we do the job properly for our clients. So with that, I'll hand over to Murray Teale. Oh, sorry, one last thing, Murray. For anyone who might have questions, if you could just pop the question on the chat box, which is on the bottom in that toolbar, just pop them up there and then I'll aggregate them and we can just convey them to our speakers at the end of their presentations. Over to you, Murray.
Thank you. Just a second. Thank you very much. I'll just put the screen up and just make sure we've got the screen up. Can everybody see the screen?
Yep, that's come up good.
Excellent, excellent, guys. So excellent work, people, for getting through the first hurdle of the day. But now there's some excitement. We're going to talk about standards, and there's nothing more exciting than talking about standards as far as I'm concerned. As Paul alluded to, I'm the Technical Director of BGI Services, who is a NATA inspection body. I was the chair of the communications working group that developed S008 and S009 in its current form, and I also chair CT1, which is the standards that deal with the 11801 series. I'm also the head of delegation for Australia onto the International Standards Group, and I'm doing some other stuff related around the standards today. So there's been a couple of fundamental changes that's occurred over the last couple of years, and what I'm trying to do today with today's presentation is just to bring everybody up to speed with what those changes are. So basically, we're going to have a chat about that today as to what the changes that have been implemented and what the impact is on that particular thing. So these are, and I need to put some glasses on potentially, in fact I will, don't get old. Basically, the 11801 series replaced 3080, and in the 11801 series, we basically, and sorry guys, Nicholas, a couple of you, can you put yourself on mute, please, because we're getting some background, and I'm not sure how to mute you all, so thank you very much, guys, much appreciated. So the 11801 series came up and deals with generic cabling in different spots. What Australia did, because we had a need, was we developed some modular plug terminated links, and we defined a test method for those. So those were included in the 11801 series, and we've now got that. For those, it's a patch panel to a plug on the end, and used typically for things like cameras and WAPs, that can be used elsewhere. We had a new standard in 2020 called 14763-2, and that's basically dealing with the implementation and operations of customer cabling. So that was all fairly interesting. That standard came in with RP1, RP2, and RP3, which is remote power. And because we're starting to see more and more remote power being fed in on our systems, we're now going to have to take to address how we address heat rise. And what happens when we start to address heat rise is that we may find that the 90 meters that we have known to come to love may not be enough. We may have to shorten that length to address the the cabling, heat rise, and to make sure that things will operate. So we may see that length go down to 80 meters depending on your circumstances, and it depends on how you bundle your cables, how you do it. I'll speak a little bit later on about that. The other thing that was introduced is DC resistance unbalanced in 4763-2. Now, this came in 2020, and its major aim is to address delivery of power over comms cabling. And it's basically saying if we start delivering 100 watts of power, 500 milliamps per conductor, 1 amp per pair, then we are really going to start to see the cabling starting to take some heat. Now, the other thing is because we run both power and comms down that cable, we can start to see that if we get this wrong, and there's a DC resistance unbalance within the pair or between pairs, we actually may flood the balance at the end, and as such, make the system non-operational as far as communications. And we can certainly turn off and with some of the safety features, get the thing to restart. So it is a bit of a problem. Now, the other thing that's happened in this, we introduced a standard called 11.801-6. Now, 11.801-6 was introduced 2019, but it seems to be that we've not really embraced this yet or embraced the concept of this yet. So it's got a minimum of category 6A. So that's the minimum, and it's wireless access points and cameras are covered by that. So cameras and wireless access points are now addressed by 11.801-6. And we just need to understand that 6A is aimed at supporting that particular application. And we'll talk a little bit about what protocols are needed to actually be guaranteed to work. But again, if you put a cable in that is not 6A to a camera and WAP, it's not illegal according to, not against regulation according to S009, but you're certainly not meeting the standard. You're certainly not meeting the 11.801 series of standards to address that particular point. So as long as you're prepared to accept that it doesn't meet the standard, much like using a cable for a patch cord less than 0.4 millimeter is not meeting the standard, you can make that decision, but that's your decision. And as long as you've documented it and you indicated to the end user that this doesn't meet the standard, you're pretty well addressed. So you just need to understand that because you can buy a product on the shelf doesn't mean that it meets some performance criteria. It doesn't actually meet the standards. And we've had to take some action within the standards to actually address that particular things. We've introduced some requirements along the way to try to address the misinformation or the mispositioning of products in the marketplace. So S009 and S008 have been changed. They came in 2020, we introduced some cables. And one of the things that has transitioned from where we were previously to where we are now is previously S008 and S009 were obviously worried about electrical safety and the ability to address the ability to make emergency telephone calls. So emergency telephone calls were fundamental in the approach. Now, the Telecommunications Act of 97 still addresses health and safety, but the definition of what health and safety has transitioned because of the change in technology. We have now got higher dependencies on health and safety on systems. So installing cabling systems will have an impact on health and safety. So the standards are starting to address that. And we've strengthened the fitness for purpose clause within S008 and S009. In fact, we're currently working on strengthening it some more with some clarity through Comms Alliance, where we're working on what this particular means. And I'm actually chairing a group that's dealing with what health and safety means at the moment. So if you think about assisted living areas or hospitals, what systems run over communications cabling infrastructure, it's basically there's a lot of life dependencies, a lot of safety dependencies on the issues of having cabling installed correctly. Now, the primary driver of this is not basically to build in any form of redundancy or anything else. It's just basically saying there is a minimum standard that we meant. If you put this in, it's fit for purpose. So I put a data outlet in, then I'm expecting a certain level of performance. I'm expecting that to work well. I'm expecting the product to be approved. I'm expecting us to follow the design criterion laid out there, and I'm expecting to actually meet minimum testing requirements to actually ensure that what I've delivered is actually safe. So we look at some of the changes, and there's obviously lots of changes in there. So I thought I'd pick out the key elements out of this to describe what we're dealing with here as far as the slides go. It's basically what we're trying to achieve. A fitness for purpose clause was introduced to S008. It previously didn't have one. Now, I know fitness for purpose is a fairly broad subject and broad obligation, and there was some queries about why we put a fitness for purpose clause in. A lot of to do with it initially was around patch cables. So people would get some patch cable, manufacturers would get some patch cordage, get some plugs, clip them on the end, Cat6 plugs, Cat6 cable, and then sell it as a Cat6 patch cable. And when it didn't work, they basically said, well, we don't need to meet, it doesn't need to work. All we've got to do is meet S008. And the expectation from anybody buying a patch cable is that it would do more. Now, there's some other regulators that will have a point to say about that, but we really introduced a fitness for purpose clause to actually address that style of issue. It's also the use of very thin gauge patch cords, and they're a really good idea in theory, because you can put a whole lot of thin patch cables on your patch panel and they look great and they're easy to use. But what we found is that if you start digging into the specification sheets on those, they're not all saying that they can address PoE. So at the 100 watt PoE is not necessarily suitable for those particular cords, but they don't necessarily give you that information. They provide it in a sheet that you've got to go off and look at and basically get and make an assessment on it. And we don't really address the patch cable heat rise because it's outside of the 1101 series. So 1101 series 0.4 millimeter is what we're talking about. So it's basically we need to 24, 26 AWG, somewhere around 26 AWG is where the standard kicks in that sort of term. And then some of the other problems we've had, and this is probably more of a heads up, we've had Ethernet cables being sold in Australia in 2021, where the spec sheet, not the product itself, but the spec sheet said this cable doesn't meet S008 compliance, shouldn't be used for cabling. It's made a statement that says it's an Ethernet cable, and yet it's basically said it's not suitable to put in. We've had other products with that plastered on the outside, but ACMA did have a discussion with them, and I believe that's been now sorted out. But again, the expectation that the product is approved is an assumption that you make, and you may just need to have a better look at some of the sheets. Things like underground cabling, say underground fiber cable, has to pass the water penetration test. So you can buy a cable that says this cable is suitable for indoor-outdoor use. It is approved for indoor-outdoor use. And then you'll find out it's not approved for underground use. So approved cable in a particular application, not being approved for that application. We started, so that's S008. S009, it took us a little while to go through, and part of the reason it took a while to go through is because we introduced new terms. So we got rid of ELV, SELV, and those types of voltage classifications, which were all current limited, and replaced it with ES1, ES2, and ES3. So we've now broken any ties that we had to the electrical world, and we now achieve safety by and voltages and currents by dealing with ES1, ES2, and ES3, which is an energy source. So energy source complies of voltage and current, and basically what came out of that is ES3 is hazardous. Now we've had hazardous telecommunications cable before. Hazardous telecommunications cabling like LV telecommunications PA cabling would be a hazardous telecommunications product. So guys, we had to tighten the fitness for purpose clause yet again for this. Again, a lot to do with modular plug terminated links, where people were going down to the local wholesaler, buying some plugs, crimping on the end and plugging it in and hoping it worked. The unfortunate part about it, there's a lot of live dependencies that were associated with that. So cameras and freezers are used for protection of personnel. If that fails, then there's an issue. A panic point or a suicide point in a prison or watch house. Basically, if that fails, somebody dies and there's a coroner involved. Cameras failing at universities where basically people have been attacked and they thought they would be protected. Panic points not working. So there's a whole plethora of different reasons why this is basically suitable. And the fitness for purpose clause is also aimed at things like, if you're going to sell a cable or you're going to put a cabling in, you've just got to make sure that what you're doing is suitable. You don't want to have something I've been involved in recently for a hospital where the backbone cable was 150, 160 meters long. And that was meant to be supporting 2 floors of a hospital with a long cable run. And their response was, it meets SW08 and SW09. So the fitness for purpose clause, for me, is one of those things that we can actually say is a problem. Some of the other issues is new earthing requirements for distributors supporting external cables. This is not so much the carrier cable coming in. So if you've got an external cable going out to a camera or WAP or access control or something, that cabinet needs to be now earthed. And that's to address lightning protection. So we're starting to put more sensors and the like outside. So that external cable has to be, that distributor supporting that external cable has to be earthed. So it is basically a mandatory requirement with those cabinets now earthed. Laser safety requirements. It is a part of SW09 that all cabinets housing lasers equipment need to be labelled by the installer. Also, again, need to be labelled by the installer if you've got laser, and there's a starburst and a warning sign on the outside of the cabinet readable, one on the inside of the cabinet, and for every panel that includes fibre, a little starburst, a little triangular starburst I'm sure you're all aware of. We've set a minimum size for installed cabling, which is 24, equivalent to 24A AWG. AWG is not a definable term and it means different things to different people. So it's ohms per meter, but that's the gist of it. It's deemed to comply, sort of, if it's 24 AWG. And we've also went through a fairly lengthy and arduous discussion about fire sealing and clarity about what the fire sealing is. So in broad terms, if you break a fire seal, you've got to restore it to that back again. So if you go through a 2-hour firewall, you've got to restore that back, and it's up to the installer to make sure that's done. He can ensure that being done by approaching the end user and saying, that's broken, can you fix it? Or because some people have their own procedures for dealing with fire sealing, but that's certainly something that we need to be aware of, that fire sealing is a thing. Again, with that hospital, all the fire seals were broken and there was no attempt to replace it. So that's the broad gist of what we've done with SW09. There's some other standards we deal with that I thought I'd just run through and just give you a list of standards, because I know how much you'd like to have a list of standards. 30129 is the earthing standard. So this is a bonding and bonding standard. So this is equal potential bonding rather than protection. And this is just making sure that your communications is basically will work. It is a compliance requirement of the 11001 series that your cabling meets this standard. We've got SW08 and SW09, which you should all know and love. These are mandatory standards called up on the Telecommunications Act 97. They're called up in the regulation, and there's no exemption for this. You can actually do an engineered design if you're an engineer of the suitable quality to outside of that, but that means you take on the risk, and the risk is yours for actually doing that design. Now, the reason that we argue about and discuss and come to an agreement on something, and it involved a whole lot of other different decision-making processes. So if you make an engineering call, there is some risk about it, and I'm happy to say that I'm not going to do any of those risks. There is an Australian Centre on Risk Measurement. I just thought I'd add that in there because what we do daily is accept risk or transfer risk or mitigate risk. And basically, this is a good document to actually start thinking about what you're doing. 4763-2 is the implementation and operations of customers' premises cabling. And we'll talk about compliance a little bit later on about how we make sure that things are compliant. But this is the standard that will actually need to be implemented for every single installation. There's no exemption for this. We need to have that specified in. We'll have a talk about that a little bit later on. 4763-3 is the testing of systems, fibre optic systems. 2967 is basically the fibre optic cabling system safety standard. So this is basically, if you're working on this, these are some of the systems that we put in place for safety. So the 11801 series excludes safety. This is the Australian version that basically looks at safety. 3084 is the pathways and spaces in commercial premises, and that's quite a well-written document. And it's got parts of it in 4763-2, but we're ahead of the world yet again in what we're developing in standards. We basically developed modular plug terminated links probably 3 or 4 years ago, and basically the world's caught up with us now and have got one. 3085 is the basic requirements for communications cabling system. So you want a method of documenting what you've got and administrating it. That's the standard for you. 62368.1 is the document I was talking about, where it defines ES1, ES2, ES3. It defines what an ordinary person is, what a skilled person is, that type of information. There's a current TR that deals with customer premises and end-to-end links. That standard it's still in place, but it's been superseded recently. So just be aware that if you've got that in your spec, you probably should pull it out. 61935.1 is the testing standard. So if you've got a fluke tester, this is what it's compliant to, or any of the other testers. It used to be an Australian standard. We used to do a text adoption of this, but we couldn't keep up to date when things were happening. So we just dropped the Australian version, and now we just go with the IEC version. So you've got the AS/NZS 61935-1. It's been superseded and withdrawn. Batch 2 is the same thing. That's dealing with patch cords. So part 1 of 62368.1 is the international standard. We've made some of the international standards, some of the additional requirements for addressing our electrical standards here. 62368 basically is dash 3 is basically all the remote powering that's carried on communications cabling, RFTC and RFTV type things. And we've got some of the international standards which we talked about before. Sorry, 14763-4 is new. It's an ISO IEC standard that is new. And this is the one that's going to address both basically modular plug terminated links, which is basically a patch panel at one end and a plug on the other end. And then we've got something called end-to-end links, which is basically a plug on one end and a plug on the other, going from point A to point B, typically used in data centers. It is a installed patch cable, basically is what it is. A patch cable is defined, and it doesn't meet the requirements for that, but the test methods will be exactly the same, except you can vary your length. So if you've got a permanent link, that's outlet to outlet. A end-to-end link is plug to plug, typically aimed at data centers in the data center space. And last but not least is the automation, the automatic information called AIMS, which basically supports what we're doing with the automatic management systems of comms. So most of the vendors have a system at the moment that is aimed at basically providing you information and some level of control over your different systems. Then we've got the 11801 series of standards that are out there. And basically what I've done is I've just looked at a couple of key elements for this for you. So this is the standard, and I don't know if you can see that. I'll just put a laser pointer on, so I'm pointing at things that you can see. These are the classifications. This is the areas that they address. Office premises, the old 3080, industrial premise, homes, data centers, and this new one, distributed building services. These is the minimum class specified by the standard, and this is the cable type that's equivalent to that. We've increased our range, so 3080 used to be 2,000 meters, it still is, but we've got industrials at 10,000 meters and distributed building services at 10,000 meters. So we've had to change some around some of our testing and other requirements to address those extended lengths. Obviously, if you've got a cable going more than 2 kilometers, like a fiber cable, we need to have test parameters for that. And there's some unique challenges that come from having cables going over over 2 kilometers. This was the old structure that we had in 3080: camp distributors, building distributors, floor distributors, and consolidation points, and then a TO, and then a patch cable. 1101 now looks like this, with 4 distributors in the model, and going out to a consolidation point, or something that's lovely referred to as an SCP, service concentration point. So if you look here, campus distributors have made it just about all the way through, building distributors, floor distributors. So we've basically got other things, intermediate distributors. We've got SOs, EOs, equipment outlets, service outlets, and BOs, broadcast outlets. So we've got the changes, but the key elements here would be you've got a range and you've got a minimum performance level. And I thought I'd just, for those who are, and I know some of you I'm telling you how to suck eggs, but it seems to be a challenge sometimes when I'm reading some specifications that we sort of get a little bit confused sometimes about this. If we buy a component, according to the 11801 series of standards, if we buy a component, it has a category rating. And that's not a typo, it's Cat 5, not Cat 5e. It has a component rating. And basically, those component range deal with certain frequencies. And so I go down and buy a Cat 5 jack, I could go down and buy a 6A patch panel, I can go buy a 7A cable. So all of those things we get and buy, and we buy something from a wholesaler, that's what we're buying, a component to go into a system. What we do with those components is we construct a system. We are constructing a system on site, and that system has its own rating. If you basically take all the Category 5 components, follow the 11801 series of standards, and implement that as a system, what you'll end up is a Class D system. And those go down, E, EA, F, FA, Class 1, Class 2. So components is a category, and basically a system is a class of system. We've got a class of system, we've got a category of component. Now the Americans have their own way of doing things, and they have categories for both, but we have a category systems, and we can either do what they call a component up approach, which is basically saying you buy all the right products, put them in and install it, then you're going to be absolutely fine. And then we've got another way of doing, which is a channel down, which is basically you meet the channel. Now, again, this is the just on the requirements again for the cabling. This is out of 11801-1 now. This specifies what the minimum categories are, and I'd like to point out a couple of things here, if I may. 10 base T, 100 base T works over Cat 5 cabling, and that's straight out the standard. 1000 base T works over Cat 5 cabling. So Cat 5 cabling is good for that. So we develop 100 base, 1000 base, 10, 100, 1000. And we went from Cat 5 to Cat 5e to get that 1000, and we renamed it Cat 5. Then we stepped up to 10G, which was 6A cabling required. And then we came up with Cat 8, which could handle 40G, but only at 30 meters, 26 plus patch cords. Then we started filling in some of the gaps, 2.5 and 5 gig. And the 2.5 and 5 gig are wireless access point sort of technology. And this is to reduce the cost on the electronics at the end. So 2.5 and 5G were implemented to actually reduce cost on the active equipment. However, the thing to note about this is what this is lifted straight out of the standard. So this is not my opinion, this is what the standards are saying. If you go out and look at products at 2.5 and 5 gig, they will tell you on their spec sheet that it will work over Cat 5 and Cat 6. They'll say that 2.5 will work over Cat 5 or Cat 6, and they'll say 5 gig will work over Cat 5, Cat 6, which is absolutely true. I have no doubt they're not lying to you, but what they're failing to tell you is it won't work at 90 meters. There is no guarantee that it's going to operate on any length of cable. And if you want to guarantee it's going to work, it's going to be working, it needs to be 6A. So 6A is this. Same thing happened with 40G. 40G was a great technology. We absolutely pushed the cabling to a limit. And then we basically went, you know what? It's expensive. We're not really using it. So they said, let's cut down the speed, because what we wanted to do really is form 100G out of 4 of these or a number of these links. So we cut it down to 25G, and basically we could get it to work at this. And if you want 100G, you put 4 links in. So this again was a cut back on this to reduce the cost of the componentry. Now, at the moment, there is some debate going about what we should do with 1 pair. Should we meet the IEEE requirements for it, or should we come up with a future-proof cable? And I'd like to point out at this stage how future-proof's worked out for us. If you look at this table and you look at the standard, what you're going to use category 6 for, I can't see an application in this table what category 6 is used for. Now, I'm not saying category 6 is not a great cable. It's really good for carrying power for a start. But it's got this, and we don't need it basically, but we've got it specified, so it's good. And Cat7 was another cable, really good in concept, lots and lots of things. And it was basically the concept of build and they will come. Well, we built it and they didn't come. So while it's not been a problem up to now for this, we're going to go through the same debates in 1 pair cabling, which we'll talk about a little bit later on. So 1 pair is going to need to either meet the IEEE requirements as a minimum, or we're going to invent a cabling system and not support the IEEE application. So to me, it's black and white, but we've got lots of people pushing back the other way. So I'm not sure of the rationale behind that, but we warn people about what's going on. I thought I'd share this as the objectives. The 1101 theory covers basically 1101-6 covers both the balanced cabling and optical fiber cabling. So it's basically covering what we normally cover, fiber and copper twisted pair. And it's non-user specific services. So this is a service not aimed at a human, it's aimed at something else. And it can also incorporate the supply of power. So 1101-6 is basically a non-user service, so device-to-device sort of connection for things and supply of power. So we start saying, well, what does that mean? What sort of services are covered by 1101-6, and which one should I be designing to? Telecommunications, and this is a lift out of the use case, wireless access point, distributed antenna systems under telecommunications, cameras. I'll let you read all of this, but intelligent building, all this sort of stuff is built into the 1101-6. The cabling that interfaces to equipment will be 6A as a minimum, but if you've got other proprietary cable going out from that, so you go to a box and it's got KNX in it, the cable going to the KNX box will be 6A. The other cabling around that KNX would be anything else. So it's not saying all cabling has to be Cat6, it's just the interface. And it's either going to be an interface of basically a service concentration point, a CP by another name, or a service outlet. But those need to be a minimum of category 6. In 2020, we introduced DC resistance unbalance as a requirement for internal transmission requirements. So this is an internal transmission requirement that is basically we have now that's additional testing. Now, the great news is, and I'm sure some of the other testers you've got to get the modules for, but the Fluke, which tends to be about 95% of the market, has the ability to do DC resistance unbalance testing as a standard feature. DC resistance unbalance is all about handling power over the cable. So its ability to handle power over the cabling. We put down communications and power down to the cable at the same time. So communications power go down this cable at the same time. And what happens if we get an imbalance in the cable is if this one's high resistance is low resistance, then more power will go down the low resistance, unbalancing the cable. And we get more heat rise where the unbalance has occurred in the cable. So we add to the heat rise and unbalance. And we've got a non-distribution of that circuit going over. So it's more prone to noise and it got higher because we've unbalanced the cable, higher attenuation in the cable. So we've got an increase in signal loss and an increase in noise. And the other thing is we get the voltage too high, we flood the balance at the end, we can't pull the data out. And additionally, the devices try to protect themselves, and they protect themselves by shutting down the power. So you can have an unreliable device at the end. Now, it's about 1 to 3% of sites when you start doing this test that are basically going to get kicked up, and it's only punching it down better. Just doing a better connection will address this problem. So it's not a huge problem as long as you look for it. If you don't do it, then you've got all sorts of weird and wonderful stuff happening on your PoE devices. It could be anything from a phone to a camera to a WAP. Anything that uses PoE will suffer as a result of DC resistance unbalance. We're dealing with we're dealing with something now called RP1, RP2, and RP3. This is remote powering, and this is to deal with heat rise within cable. Now, we start looking at heat rise in the cabling, and 14763-2 gives us a lot of information, along with a TS 29125. Gives us a lot of information related to heat rise within cabling. The size of the bundle is the contributing factor. Where the cables are installed, are they in insulation, or are they free in air, or are they in conduit? The duct will have an issue, and how many conductors are actually, and what level of power are they actually carrying? So, is it constantly on, or is it just on sometimes? So we've broken it down to RP1, RP2, and RP3, and this starts where we start to look at discounting of length. Now, a couple of the vendors have calculations for their gear, and that's a really good thing. There are some calculations for this in 14763-2 if you want to get a head around it. I've got my own calculator that I use internally to make sure that I know what I'm talking about. And I've got Peter Mayer to develop that for me, if you remember Peter. And it's basically just a useful thing to make sure that what people are telling me is somewhere close to factual. So there's 3 levels. And if you've got 200, if the cables on average, you've got less than 212 milliamps in, at any one stage, then you can call that RP1. But RP1 means you've got to control about what you plug into the cable over its life. So attachment of remote equipment will change its rating. It's basically, it'll take that up. So if you put in something 100 watt PoE, that's going to up the end. So we need to have some controls about what we put onto the cabling system, and we've got to actually have some planning done for anything else that we start adding additional cables. That's going to add additional heat load to that particular cable. Now, when this first came out, RP2, I wasn't overly convinced that anybody would use. And this is an engineered design, basically, between 212 and 500 milliamps per conductor on the cable. This is per conductor, so 500 milliamps is 500 milliamps per conductor, 1 amp per pair. And basically what people are using this for is to actually say, well, this is the style of technology I've got running out of my cabling. Some it's going to have PoE 100 watts running all the time, and some it's going to be less than that. And so what we can do is, if we get the mix right in the cabling, we can actually do this. Now, it's basically, again, attachment of the equipment's going to do it, and you need to have some power. You need to engage somebody, or do it yourself, to do the calculations about where you sit with this. And the key element of this is we're going to have to work out how much heat rise we're going to get and how much we're going to have to discount the length of the cable. Now, what will add to that discounting is if you start using smaller gauge cable. Now, Australia has said that we've got a 24 AWG minimum on that, but if you start putting in really thin patch cables, then your calculations are going to have to change for a whole range of reasons, including a length measurement will be affected by thin patch cables. The heat rise in that will also be affected. So for every thin patch cable, for a normal patch cable, for every meter of patch cable you have, it's equivalent about 1.5 times as long in the cable. So if I add an extra meter of patch cable, I've got to discount my install length by 1.5 meters. So just be aware of that along the way. Now, RP3 is basically, I'm going to use this. I don't want to do any worries about any connections. I just want to actually make sure that everything's going to work. So I'm going to call that RP3. That's 500 milliamps, always operating. Now it's possible, and I thought this is the way the market would move. It would move to this way until we start looking at the length restrictions. The hotter the ambient temperatures, the less length you've got. So we're talking about 10 or 15 degree heat rises with good cabling, and 60, 70 degrees heat rise with very thin cable outside the standards now in confined spaces. So this became an exercise, and we've got people down with cable runs down to 80 meters now as a maximum, and I wouldn't be surprised if they go less than that, trying to achieve this particular requirement. So this is something new, newish. Some of the vendors have taken more interest in this than others, but at the end of the day, we will continue to work on 4763-2 to improve it, and the vendors will provide us some information about what they believe their cabling system's capable of doing. I'd like to see us get 4763-2 to a usable point, so we're not reliant on proprietary systems to actually get there, but it'll probably give you some good guidance as to what you may be putting there. And certainly you don't want to be, well, length's not a pass-fail criteria under standards. It may well put you into a position where you start considering that, maybe 90 meters is not the longest run, is, not a run that I want to do anymore. I might do mine down to 80, just give myself some protection. Energy sources, ES1, ES2, and ES3. So put simply on ES1, ES2, and ES3. ES1 has no voltage limit as long as you've got current limiting. So, and the scope goes up to about 600 volts. So you can have a service that's around 600 volts on a comms cable, and there's nothing against that in the standards, except the current has to be very, very low to address it. Equivalently, you could have something that has got lots of current in it, but very little voltage. So we've got the two possibilities. Now, there's a limit for voltage and a limit for current. As long as you meet one of those two limits, you can do anything else with the rest. So that's ES1. ES2 is just the same, but a little bit higher. So basically they're saying there's a voltage and it comes up to a higher level, or a current that goes to a higher level. And as long as you meet one of those two, either current or voltage, you are absolutely safe to call it ES2. ES1 and ES2 are basically safe. ES2's got some potential for hazards for fire, but not for cabling. Typically not for cabling. It's more of a thing at the devices themselves. So ES1, ES2 is safe. You're not going to die from touching it. It might hurt you a bit. I may die because I've got a pacemaker, but you won't die. ES3 has no voltage or current limit specified. So they're basically saying this is dangerous. This is a dangerous cable. It's the equivalent of the old LV telecommunications cable. So it's, get our heads around that. It's basically saying we've got some hazardous telecommunications cabling, and it'd be awfully embarrassing for Sparky to get electrocuted by a comms cable. When you start to look at this, and the thing that people get concerned about, it's a touch current, not a circuit current. So it's when you touch it, what current's going to go through your body, not what's going around the circuit. So the numbers look lowish, but you just need to actually work out it's a touch current, not a circuit current. We have not applied any requirements to ES3 application-specific cabling. We're leaving up to the vendor of the product who's selling that to actually specify. So you're putting in a PA system, the PA people will tell you what sort of cable to put in, you follow that, and then you meet your fitness for purpose clause, and the safety obligation goes on to them. If you start changing that cabling around, then you've got your fitness for purpose clause comes into there, and you might have to prove some engineering that you're not going to kill people. ES3 by its nature is hazardous, so we basically have to warn it. Now, the other one is ES3 generic cabling is basically able to be limited somewhat by S008 and S009. Somewhat. I think it's around the 600 volt mark. It's not somewhat limited. And what we've tried to do is limit it some more by saying whatever current we've got running over cabling that's specified by Eliminator 1, which was 750 milliamps, may go up to 2 amps per conductor very shortly on one pair cable. So we've got this particular thing. Now, we don't really want to encourage this. So an RFTC and RFTB circuit would be, so carriers use this to get their services to a place to do remote powering, and that could be very high voltage with low current. So it's basically still hazardous in some form. So we came up with a cable that's Homebush Gold with red writing for generic cabling. Now, if you don't think you've seen too much Homebush Gold with red writing on it, there's a good reason for that. Because part of the discussions that we had with manufacturers of this said, what cables color don't you have at the moment? And these are Australian colors. So Homebush Gold with red writing, it's actually Homebush red writing. So which ones don't we have? And that was the first thing. And we really want to discourage people from getting in this, because we don't want to present hazardous cabling to end users who can do it. We had no method of exempting this. I would imagine as time goes on and as we work towards health and safety, that this generic cabling supporting ES3 cabling will disappear. And I'm not aware of anybody installing this cabling yet. And I think there'll be a whole range of dangers with it. There's a whole lot of labeling that goes with this and some protections about where you put this stuff. So I don't see any great value in this. If you want to put it on a PA speaker, then put in some figure 8 cable or whatever else is there. Modular plug terminated links, quite new. Patch panel going to a plug at the end or going through a SCP. S009 supports this in part. So that again, S009 supports the use of modular plug terminated links. However, this plug here at the end has to be out of arm's reach or in a secure location. The exemption for end users plugging into cabling, because an end user is actually doing cabling work and a cord is exempted from regulation. So patching up a cord for an end user customer is exempted. This, however, is not a customer cord. This is fixed to the sealed cabling and is covered by S009, and that plug would have to be installed by a registered cabler. Now, these plugs are causing harm because of failure operation. So people are going down and getting their own, crimping them on and saying it's never been a problem, right up until somebody gets hurt. And then it is a problem, and then it's rolled out. Was it fit for purpose? What was your method? So this is part of the reason why Australia developed a modular plug terminated link testing method, because we needed to actually see if this is correct. Now, Cat5 is pretty easy to get something to work with Cat5. Cat6, a little bit more difficult, and Cat6A is quite difficult to actually get. So we've certainly seen ourselves some plugs being, field terminated plugs that just look like the normal RJs being sold at 6A. We can't get them to work. We can't get them to actually get at 6A. And I thought it may just be that I'm old and I'm incompetent at terminating anymore, but I've got some people that I've had several people that are, have their life doing data cabling work who can't get them to pass either. So there is different plugs. Some of them are little PCB little boards that you plug down, others there, but these plugs hold a lot of dangers to people because they may not be fit for purpose. And if there's any sort of injury that's happened, this style of plug has been responsible for taking down a major international data center twice because of poor terminations. So they decided it's there, and it's quite difficult if you've had everything to do with data centers to take a data center down once, let alone twice. And I can't tell you which it is, but if you go back probably 4 or 5 years ago and have a look at that data centers going down in Sydney through storms, and you can't get your pizza delivered, that's the one that was caused from a plug failure, where somebody decided to save some money on making up patch cables by actually doing their own stuff. To do this, to actually do a test, you need to have a patch cord test head on one end, a permanent lead on one end, and a patch cord test head on the other. These things look exactly like a channel adapter. These things look exactly the channel adapter, but they can't do. The plug on the end of on the end of a channel isn't formed part of the test. So that plug at the end of on the channel adapter is just negated out when it does a test. So we need to have patch cord test heads. Now, the unfortunate part about these is they don't come part of the kit, and you've got to buy them separately. And they're about $1,200 to $1,500 for a set of two. So people are doing it, but the test method is basically somewhat where you can't get this now. And the other thing is you need to have a Cat 5 one, a Cat 6 one, and a Cat 6A one. So I've got 3 different sets that I use because I need to, the standard says I need to have each of the 3. Now, the standard 14763-4, the IEC standard 14763-4, basically follows very closely, if not identically, to the requirements of the Australian standard. So the Australian standard basically was held up as a model, and basically they went forward and basically did the work, came up with the same solution to us, same issue. So there's no respite for you getting away from this. And if you're going to do these, it's supported by the standard. As I said, the cord, the plug at the end has to be out of arm's reach. It has to be either secure, so you can't have it going out the wall and plugging into a device where an end user can get it. So these are, and there's requirements for movable cables as well. So it's of interest to us, particularly because it's causing grief. If there's anything that's causing copper grief at the moment, where it's impacting life and harm more than anything else, it's those particular plugs. Now, compliance. Just about every specification you read says you must be compliant to the standard. And for the standards that we've got now is the AS 11801.2 series of, 11801 series of standards. And I thought I'd just share with you what the compliance section says. There's a whole pile of stuff about being compliant, saying that you've got to do, 30129, and you've got to use this, these links and these channels, and it tells you a lot. But in this is the office space, and this is the conformance section, section 4. So go to the standard and find these words. This document does not specify which test and sampling level should be adopted. So that's a statement about how you comply to 11801. And 11801 says, we're not going to tell you how to do an installation performance test. We're not going to tell you what sort of testing you need to do. We're just not interested in telling you that. But within the same clause, it says the test parameter to be measured and the sampling level to be applied to a particular installation shall be defined in the installation specification. So it's got to be defined in the installation. It's a normally requirement if you're going to comply to 11801-2, which is basically what you've written in your specification, say you've got to comply to. Then your specification has to be specify what tests to be done and what the sampling levels, and the quality plan for that installation prepared in accordance with 14762. So there's a quality plan required for an installation. So 2 things out of this: we're going to specify what testing we're going to do plus a sampling level. That's okay. And then we're going to write a quality plan and basically work out what's going to go on from there. Now, sorry guys, we've got an E233789. Can you mute yourself, please, mate? I can mute you. I think I can. Look at that, the technology. Okay. So, gentlemen, who's responsible for this? The building owner. The building owner is responsible for doing an installation specification. Okay. And that will meet standards, any vendor requirements, any sampling level, and any end user requirements. So they'll basically look at this, the standards, end user requirements, vendor requirements. They'll look at the whole shebang, and then they will write a specification, give that to the installer. It is the restorer who is responsible for writing that quality plan. The words are the quality plan will be written by or on behalf of the installer. That means if you've done a project and you haven't got a quality plan meeting 14763-2, your job is not compliant. If I come on site or somebody else comes up and there's been a problem on the site and we're trying to work out, does this comply to the standard because you're obliged to meet the standard? The first thing I'm going to ask you for is the quality plan. And that's going to be interesting. So what does the quality plan, or what could the quality plan entail? Given that I'm the installer and I've got to write one of these things, the obligation is you could do 100% basic testing. That's the only thing that you've got to do is 100% basic testing. For copper, that means a parent continuity test, get all the lights blink in the right order. And for a fibre, its polarity means you shine a line down one end and you get out the other. Now, if you meet those requirements and the customer's happy about it, you are meeting the standards by delivering that particular job at that particular level. But if you're writing it and you're trying to protect yourself and mitigate risk, I would suggest that we look at some more. So we then start looking about internal transmission requirements. And for copper, that is you grabbing your flute tester, going class E or class EA, and then putting that on. Understanding that we have to put the word plus all or plus POE to get DC resistance unbalanced, and we do that. And we basically go through and do all the internal internal transmission parameters. Fantastic. On fibre, we look at loss, length, and propagation delay. Loss, length, propagation delay is going to get us there, along with polarity that we've already established by the basic testing. At 6A and above, we're going to draw Teale crosstalk. Now, Teale crosstalk is basically the standard says if you've got a cabling system claiming to be compliant, minimum cable run is 15 metres, maximum cable run is 90 metres. And we've got a lot of cabling that goes less than that. And we want a statement from the manufacturers anyway to say their stuff is compliant to crosstalk met by design requirements. So what we get from them is a statement of compliance rather than do field testing. Now, you could ask, and there's nothing stopping you if you have deep enough pockets to ask for Teale crosstalk testing, 100% Teale crosstalk testing. The problem is that you get through about 3 outlets a day testing for Teale crosstalk. I'll say that number again, 3 outlets a day testing for Teale crosstalk. And if you fix a problem by changing any of the cables around, then you've got to retest that particular thing. Not only the cables, the thing you were testing the first time, but any other cable bundle that you've shifted that's been tested, you'd have to change that around. So this is an endless loop of paying for somebody. And the way to avoid that is having a statement from the manufacturer saying, this is the conditions that you need to meet to ensure that you don't have to test for Teale crosstalk. This is the most common method of achieving this in Australia at the moment. And the measurements and the sampling level for all of these things, except for Teale crosstalk, 100%, basically both directions, both wavelengths in both directions for copper as well, and 100%. It's got to basically, in the quality plan, also, you've got to specify what the performance level of the system is, what category you want, what sort of fibre you want to do, and then the cable and connector types that you need to see on the cabling. So, guys, what's happening now? What's coming? We've got a 1-pair cabling in support of IEEE 802.3CG and BU, which is basically power over data line. It's basically power and comms going over 1 pair, and there'll be a one 90-metre sort of link. There's around a 200, 300 when we finish arguing a link, and there's a kilometre link. Now, that's the reach that we're talking about, up to 1,000 metres. The problem that we've got at the moment is we can't, as internationally, we cannot decide what we're trying to achieve. There's 2 basic schools of thought. One is that we should support IEEE as a minimum and then look at anything on top of that as a way forward, because the IEEE published standards and they've got equipment, so we should be supporting that. And then the other thought is, well, let's build some cabling systems that we can really do on cabling, but we've got no applications. And I've got to confirm this with the Australian committee yet, but my personal opinion is that we really want to support IEEE because that's where we're going to make our money. That's what we want. We want to be able to support the applications that are out there to actually work. So that's still going on, and we're spinning our wheels quite heavily on that one at the moment internationally. But this is really, 1 pair is really looking at building automation systems, looking about what we could do with 1 pair. So if you just put it in the 90 meter model, we can get 25 watts of power down there. 25 watts is enough to run a light or lights. It's enough to do a controller. It's enough to do an actuator. So we can put them down there enough to do a clock. So we can start seeing anything in the IoT space. We can get a 1 pair cable to. Now, a 1 pair cable is a lot cheaper and a lot easier to deploy. And basically, if we take it to an SCP, a consolidation point, and just having running out, I can run my air conditioning control, my blind control, my clock, my PA speaker, my EWIS system, all off the same cabling. I can add in some sensors to do some movement of people. I can do sensors for looking at CO2 content. I can look at a whole smoke detection. I can do a whole lot of things with this 1 pair cabling. So it is got a saving grace. And the killer application, or the reason why 1 pair is such a likely important cabling moving forward, is because it delivers both power and communications at the same time. The savior for copper cabling is that it delivers power. So fiber is fantastic. Wireless is fantastic. There's nothing wrong with those technologies. And I'm a great fiber supporter. But at the end of the day, what we really want with some of these devices is basically power. So the rule of thumb typically is if it's fixed, put a cable to it. If it's mobile, do it by wireless. Because you've got a mobile device like me with my pacemaker, there's a battery in there. I'm not going to connect up and walk around. But if I've got a clock on the wall and I can put up a tower, and I can put a tower up and get 5,000 devices connected very, very quickly, but then I've got 5,000 batteries to replace. Now, if those devices are mobile, that's a given, and you move things around, it's going to be fine. But if it's fixed, let's put some copper cable into it, and then we can actually not have to get up there and do things. And the SCP gives us the same sort of benefits as a CP used to do, but at probably a far more reaching aspect. So Ethernet is basically the same protocol that's used from the carrier through the building to a device. So into the campus, from the campus to the building to floor to device, all Ethernet. So it's an easier protocol. It's not proprietary, so we're not talking about having different systems that are proprietary in nature, which means it should open up a whole lot more. So it is really flood wiring for the distributed building services or IoT. Other news about things happening: 11801-1 is basically going to be replaced. Well, AS 11801-1 is going to replace AS NZS 11801. And it's basically, we're withdrawing it because we don't need to have the modular plug terminated link in it anymore, because we've got an international standard for it called 14763-4. So we're likely to adopt 14763-4 as an Australian standard in April this year, 2022. And if you can see, April is not that far off. So the work has been done, and it is all ready to go out there. The reason we're not releasing 11801 till somewhere around November is because there's a whole lot of stuff we've got to do when we change the standard, putting out to public review, getting the committee to vote on it, and basically getting endorsement for it. So that process was going to take about to November. The work's been done, and all we had to do was, well, it started off as a very easy project, but then New Zealand opted out and said, we don't want to help fund it. Just a second. Thank you, Jared. There we go. Basically, they opted out, so we had to go any reference to New Zealand in that document. I had to pull out. So that's happened. As I said, 14763-4. It's going to be put out. That's end-to-end links and modular plug terminated links. We're currently addressing the overlap in electrical and communications regulation. The electrical regulation controlled by ERAC is basically state-based, and we have a federal-based communications law. So we've got state versus federal. There's exemption currently under the Telecommunications Act for cabling that primarily covers power. So we don't have to regulate power cable because they carry signaling. So we've given them exemption. the issue is that with the new definitions of ES1, ES2 and ES3, all cabling would fall into electrical regulation and would need to be done by an electrical worker to actually do it potentially. And they would then have to say, well, that would have to be also a comms alliance, not comms alliance, have a cable registration under licensing. So hopefully that will sort out. What we propose, what's been proposed, is that ES1 and ES2 is basically going to be left alone by the electrical regulator, saying because it's safe, ES1 and ES2 is safe, it'll be left alone. And then ES3, which has got some safety concerns to it, will be handled by either the cable registration by the registrars address electrical safety of ES3, or the electrical authorities issue a restricted ticket for them to do ES3, people to do ES3 cabling. So I'm not sure where that's going to actually end up, but it is being actively worked on through the Comms Alliance, ACMA and ERAC. So new standards, we have a couple of new standards coming in the series of standards. One is on sustainability. So we will have a sustainability standard fairly shortly. And the other one is a security of physical layer. So basically, we start to worry about all this cabling and all what we do with the cabling, the impact of safety and security, that we're going to have some standards for security. So it's basically not security for the protocols. It's basically saying, can I get into the room? Can I get into the cabinet? Can I drill a hole through the wall and get into stuff? So it's basically that style of standards. So the questions, and I like, and this is sort of a segue into the next part, is how much do we do in compliance? You know, what's compliance mean for organisations? Given that we've got mandatory safety standards, so S008 and S009 are mandatory, then we've got products out there that are not compliant with S008 and S009, and we've got performance products, so the performance of the cabling systems that has an impact on safety, so, and the insulation. It's basically, you're starting to say, I need to support safety, security on my systems. You know, safety systems, security systems, and service availability are all fairly important. If you don't have service availability in a hospital, there's a whole lot of issues. If you don't have a service availability in a assisted living, there's a whole range of issues. Now, understand that this is a much broader topic than just physical layer, but the physical layer, if you don't have the physical layer being deemed to be safe at some point in time, you really do open up yourself to actually exposure. So the idea for risk, in my eye, is to mitigate the risk and just know what you've got. Unfortunately, a lot of people just accept the risk. You know, they basically do it without actually understanding. S008 and S009 are really good standards to go to. Lots of people, a lot of installers, not saying anybody in this presentation, basically say we're never going to be caught. Now, that may be true, right up until somebody gets hurt. And then you're going to see someone like myself or the next speaker show up on site. And the first thing we're going to start to do is saying, does it comply with the standard? We're going to look at the specification. We're going to say, does it comply with the standard? And does it comply with mandatory standards? And if the answer is no, then you are somewhat exposed. We've got different people with different objectives here. We've got people who are specifiers, that you've just got to make sure that what you're specifying is correct. And you're somewhat reliant on the people doing some of this work to actually understand what they're doing. But at the end of the day, you are doing the design, they are following the design. So if they just deliver what you want, they met their obligation. So it may be benefit to actually make sure that you know what you're particularly specifying. So, gentlemen, I've finished a bit quicker than I thought I was going to, but somewhat on time. Any questions along the way? Paul,
No, I'm not sure if you've been noticing, we've had a few questions posed on the chat spot. A few have been answered in the discussion, but I'll just flag them one by one and you can basically share them with the entire audience. First of all, we've got a question from Ray Trudwell. Has AS3084 been superseded by 11801?
No. No, it's the absolute answer is no. In fact, the 3084 may actually be used by some of the NBN and likes to get multi-dwelling units. So it is probably one of the most solid documents that we've got, written by Peter Gunther, and that stands now as a requirement, and it's heavily used and likely to be heavily used going forward. In fact, I'm in a meeting Thursday with New South Wales government talking about digital states, and they're looking at a deployment for the whole of government, and that's one of the base documents I'm bringing to the table and saying this is a good document for for achieving the objectives of what they're trying to achieve.
Excellent. That's great to hear.
Sorry, Paul, can I just mention, Murray, g'day, it's Tony. I think the question was regarding AS2834, which was the computer room accommodation thing, which has been long gone.
Yes, and I think you were, yes, Tony, you're absolutely, if that's the question.
Tony has, sorry.
Was it a different one?
That's a second question. You beat me to the punch, Tony.
All right,
yeah.
sorry.
And Tony, so the question and answer, Tony, that you gave is both correct.
Okay, good. That covers those two. We've got a question from Barney. Is Cat 5 or Cat 5e the minimum requirement for 11.801 3 and 4?
The 3 and 4, yes. If just a second, I'll just go back to the slides.
Yeah, sorry about that.
No, that's okay. I just need to get the technology. This is this slide here. No, not that slide there. This one here. So Cat 5, minimum requirement for homes and industrial. I think you've struggled to find any Cat 5 cabling around, but industrial, I can understand it maybe a little bit more than homes, but most people, I've got 6A in my home because I can. So a lot of people will put better cabling in their home, but Cat 5, according to the standard, and this is all in the scope. So this is my translation, so you don't have to go out and buy necessarily the standard. Maybe I shouldn't have said that, but these are the minimum standards that we look at. The one that catches most people out is the WAPs, the Cat 6A. So these are all contained in the standard. So offices is 6, industrial and homes is 5, and data centers, including anything. Basically, a data center could be a room within a building that houses equipment that stores data or makes decisions. So with IoT, data centers have changed around somewhat as to what their scope was. We went from file servers to data centers, dedicated space. Then we went to data centers in the cloud, and then we're starting to go back into premises, and we're starting to deal with things like edge technology. So we're starting to actually go back towards the edge, which is basically you need to have some decision-making power on the site. So particularly with autonomous vehicles, delivering medicine in the hospital or medical information in the hospital, you would need to have that sort of data. The ability to do McDonald's without having a connection. Because the storm goes through,
Didn't Class D Cat 5 get redefined to Cat 5e in effect?
It did, Barney. It absolutely did. So Class D went from, in 2000, it went from Cat 5 to Cat 5e. And then in 2002, because somebody had said it would be split over Cat 5, we renamed it Cat 5. The Americans kept the term Cat 5e, and we see, because people will be more inclined to buy Cat 5e than Cat 5, we see it in the marketplace as Cat 5e, which meets the requirements of Category 5. And the Americans, that term from the Teale kept that terminology going. So Cat 5 is what we've got defined in the 001 series, but it did go through a name change to Cat 5e in 2000, and then from 2002 went back to Cat 5 again with additional requirements.
But is it then Cat 5e that we're really looking at, even though it says Cat 5?
Well, it's, Barney, I think people in standards have got a great sense of humour. I think it's fairly dark humour. The standard says Cat 5. I chair the standards committee. I'm going to say it's Cat 5. But if you go out and buy a box of Cat 5e cable, I'm pretty sure that you'll find that box of cable would also meet Cat 5. So I need to say it's Cat 5 because that's what the standard says. But I don't think I've ever seen a box of Cat 5 since about 2000. I don't think I've seen a box of Cat, well, probably from 2001. I don't think I've seen a box of Cat 5 being sold in Australia. It's all called Cat 5. Sometimes it's specified as Cat 5 with an oblique 5e, just to get around that particular problem. But the TIA, and I would imagine a lot of the stuff in BICSI out of the States would have Cat5e as the term. But I would imagine outside of industrial, we're not seeing a lot of it installed.
True.
Okay,
Thanks.
move on to the next question. This one's from Tony Curry. Is one pair likely to allow 4-pair cabling to be used and divide into 4 circuits?
That's probably the hottest topic of all. And there's some proprietary proprietary gear that will allow that to happen. So an piece of active equipment will allow that to happen, or you can do it with cabling. The people who've got the proprietary system seem to be very keen to make sure it goes down that proprietary rather than the cabling. So yes, multi-core is certainly being discussed, and we're trying to get around the problem. And there is an IP issue related in that discussion internationally. So it's a wait and see. It is in that 1-pair debate.
Okay, thanks for that. Another question, is 14763-4 a direct text adoption of the ISA standard? That's raised by Craig Buckingham.
14763-4 is a modified text adoption. And the reason that it will be a modified text adoption is because we don't refer to ISO IEC 11801, we refer to AS 11801.
Okay, thanks for that. Another question, hang on, I just got to bring this up. It's computer problems as usual. Just bear with me a minute. My apologies. Here we go. Ray has raised a question. What standard do we use for computer accommodation?
I have no idea. The best advice I can do is have a look at 14763-2.
Gotcha.
But the computer accommodation was it was being withdrawn. We looked for support for people to get involved in its development, and there was no support, so we dropped it. So the most likely standard for that to be included in would be 2 places, probably 3084 and 14763-2 would be the 2 standards to look for obligations.
Okay, good. Thanks for that. We've got one last question, which is perhaps interestingly a segue into our next presentation. This is from Nicholas Bulmer. If you could share experiences of where the communications mandatory standards have not been followed. Probably lots of those.
Well, in fact, I'm acting as an expert witness at the moment for a hospital in New South Wales, and basically, I've indicated the hospital is not safe. So my advice was to recable the hospital, which is an operational hospital. So it's basically operational hospital. It's deemed to be unsafe. The hospital's position is that they deem it to be unsafe as well, because it's against the standard. So the current plan is to shut down the hospital for 8 to 10 weeks and replace the cabling in a manner that makes it safe. So that's an example where I walked on the site, asked to see the quality plan as a starting point, and just basically got nothing. And a lot of the stuff is fit for purpose. Out of that we tested some sample testing out there. I think it was 160 outlets we tested, and 140 of them failed testing to category 6, class E. The specification called for class EA cabling, the backbone cabling. Basically, well, it didn't pass testing. The cabling didn't meet the requirements, and probably the mandatory part, sorry, I went off subject. Separation was NIT 1 PERL 1 with LV telecommunications, power cabling. So ES3 and ES1 and power cabling were all mixed into the area. Basically, where it came down walls, there was no separation. There was they use Crone disconnect modules as a consolidation point for category 6 cabling. They use tape joints in the cabling. Again, that would be against the fitness for purpose. So it is something there, but the typical areas broadly about where we see issues with comms cabling is either the product's not approved is an issue, or alternatively the basically separation issue is the greater one. And the closer to the ground you are, the more dangerous it is, because we're worried about extending hazards out along the cable. And And basically, so it's basically separation issues that are probably the biggest. I've not been involved in it, but I certainly know there's a hospital in Queensland that got reworked because of separation issues. So it's a matter of what's going to cause the hazards. The things that I've been involved in outside of that, where questions are being asked around safety, is basically cameras failing in freezers, panic points, suicide points in watch houses in North Queensland not working because of failures in the cabling, and that's where it comes down to the health and safety, and that's why we're spending some time working on health and safety. If I was a consultant doing this, and one of the things I say to every consultant I get a chance to is you need to get a TCA1 form saying that they basically have said the site is safe. So TCA1 form is a normal bit of documentation that they state saying that their installation is safe. For a contractor, equally, when they sign that, tie it to your test results, because what that does is saying that when you hand over that bit of paper and you say, I provided 652 test results at that particular point in time, you tie it to a TCA1 form and you basically got a record of what you've delivered. So we still find that people don't test wireless access points and cameras. They just manipulate test results by testing something else. And we've got a program that picks it up. So about 30% of jobs have some form of manipulation in them that we find. And once they know we're looking, it goes down to about 5%. So it's reasonably good. So I think the record is 70 cables out of 90 looked very similar. And we've got another job which is 35,000 outlets where there's been about 4. So that's and I think that was an error rather than manipulation. So yes, I hope that answers the question.
That's good. Thank you very much for that. We've just had one more technical question come through from Barry. We'll just cover this briefly and then we'll move on to Peter's presentation. Wireless access points and cameras over PoE. What's better, Cat6a UTP or Cat6a shielded?
The answer is yes.
Yeah.
Look, the standards are silent on the matter for it. There is some discounting done for a shielded cable, and basically it's the size of the cable that makes an impact on heat rise. So the only thing that would be affecting is heat rise, and if you've got a cable running by itself, heat rise is not like, so going out to wireless access point, you're not going to likely have more than 2. There is a push by some to have 2 cables, and I think you'll find that coming through BICSI fairly shortly, to have 2 cables going to wireless access points, and that's to deliver power rather than delivering Comscope 6A will give us 10 gig, and I understand there's a 10 gig or close to 10 gig application being developed for wireless now.
Okay, all right, we'll conclude there with Murray's presentation. So thank you so much for that very insightful presentation, Murray, much appreciated. I'm sure we've all gained a lot of benefit from that. One of the key things that comes out of this is that we need to cover ourselves. The complications are getting more and more involved, more engaged. We as industry are more accountable, and we need to basically make sure that we protect ourselves. And Murray, you talked about this quite a few times, the issue about being able to be in a defensible position. So if there's ever any problems, if you've done the right thing, adhered to the standards and the regulation, you've got a good chance of being covered. So that's very important. Murray, would you mind just handing the host control to Peter? Or back to myself, and then we'll get Peter on board.
Oh, yeah, sorry. Yep, I understand.
He can, Peter can then share his.
Okay,
his
let me just go.
Just looking for Peter on the list of people. There's quite a few people here.
Okay. Excuse my ignorance. I know how to share screen, but how do I allow you to be taken back?
If you can just find Peter on the tiles. I'm looking for him at the moment, then right click on him.
How about I do it this way? I'm going to right click on you.
I'll right click on me, that's fine.
Make host.
That makes me host, good, thank you. I'm just trying to find Peter. Do you want to just identify yourself where you are, Peter? You might be under a different.
I'm here.
There you are, all right, good, just spotted you.
I'm waving, but you're not responding back. It's a little bit rude, mate.
All right, there you go, Peter. You're now host. So if you'd like to share your screen, and we'll introduce Peter. Peter Turnbull is, there we go, in a nice environment. Peter is Director of P2C Engineering, which is an organisation that provides forensic engineering services. Peter presented at our conference back in 2019 and sort of scared us all a little bit about the risks and accountability that we've got. And since then, over the last couple of years, Peter and I have had lengthy conversations on issues about reducing risk and obviously using standards to be our best friend. So we'll hand over to Peter to lead the discussion.
Excellent. Thanks, Paul. I've just got to make sure that these people behind me don't disturb us while we're in here. So I've asked them to mute as well. So look, thanks, Paul, for inviting me. Murray, very informative presentation. I've just understood how old I actually am and how long I've been in this industry, because I think I've actually got a box of Cat 5 still in the shed. So I'll try and get rid of it or sell it at a premium for all those people that still need to make up those installations. Hopefully everyone can hear me okay. Paul, is sound all right?
Yep, that's fine. Coming through, Peter.
Excellent. Thank you very much. Well, hello, everybody. My name is Peter Turnbull, as Paul introduced me. I'm the Director for P2C Engineering. P2C Engineering, just in brief, is a bespoke engineering house. Many years ago, I was an electrician, did data cabling right through to various jobs, and then decided that I would enter into the engineering fraternity. And then some years ago, took a bit of a career path and started P2C Engineering. The application for that business was to put back to the university, to the community, back to the industry, and support where possible. My experience in the trade industry has always been a hard task, and was taught the hard way, but I think what was the best way. And now I find that the industry is lacking support. Not everybody's got a diversity and experience. We don't know where we turn. D&C markets are taking over. Our contractual influences are starting to drive how we make money, or if we don't make money. The current media is demonstrating that, that type of way to market is not. Shane, do you mind muting, mate? If you could, that'd be great. So yeah, what we decided that was we would start to put back. We do design work, but we also do forensic auditing. And one of the things that we get involved in is working with specifiers, consultants, principal contractors, clients, contractors. And one of the things that we find is that there seems to be an appreciation for how it used to be, but maybe not how it is now. In my role, we come across a variety of interesting installations and behaviors and practices, but auditing consultants, be it on the principal contractor side, client side, or the specifier side, are starting to be more common. And one of the things that I've done and experienced in my circle is that we're starting to find a lot of contractors, installers, and certainly specifiers as well, are not fully conversant with where the industry's at and what the requirements are under the acts, the regulations, and the specifications. Now, after listening to what Murray had to say, it is very in depth, but one of the things that we're starting to see appear more often is shall and must and mandatory. So that's sort of the basis of where I'm coming from with my presentation today. And today's about reducing risk by using your knowledge and being prepared for the job at hand, the products that you require, and the market ahead of you, and your obligations. So today's is not about a technical presentation, really. It's about thought-provoking. I want to be a crack initiator and get you to start to think outside the square of where you need to be, what you need to be thinking about. An auditing consultant that comes on site, or an auditor themselves, whether it's from the government, ACMA, so on and so forth, they're very well conversant in what is the current. So I thought we'd take you down this path today. I'm happy if we can get some feedback. Usually I normally do these presentations face to face or in a room, so bear with me with this. We'll give it a go. And we'll answer the questions at the end of the presentation. All right, so let's look at minimizing risk. The things that I think that I see and come across quite regularly in the market at the moment is understanding the scope that you've got, what other third parties can influence and impact on yourself. We'll deal with these as we go through. I've broken some of these down into some more expanded detail. You need to review your contract, understand what those contracts are. I deal with a lot of legal fraternity, and the legal entities always look at what is the black and white text. But what we understand is we understand technical, they understand law, and there's always a gap in between. How do you get your point across? How do you establish that you've done it right? Because sometimes this black and white text can be interpretive. Understand what your contract exposure is. Are you taking on liabilities that you hadn't thought of before? If you do something, how does it influence somebody else? And how does somebody else's actions influence you? You must maintain an adherence to the prescribed standards. Now, there's always a lot of standards to maintain, and some may and some may not understand that a lot of these standards are mutually inclusive. So when you think you may be okay and you fit with S009 or you fit with S008, have a look at what the cross references are. What else are you obligated to? You may be obligated to other things that you may not consider when you first sign the contract. And it says you must be required to maintain compliance with all relevant standards. We see this a lot in our line of work, and a lot of auditing consultants pick this up. And sometimes it can bring an installation unstuck with something simple. One of the things I find amazing over the years, and I've been in the contracting side as well as both being on the consulting side, errors and omissions in design documents, errors and omissions in contracts. Don't think now in now's market that not raising errors or finding problems and thinking, hey, you know what, I see an error here. Here's an opportunity for me to maybe claim a variation, identify that the specification is still referring to some sort of act back in 1954 or whatever it might be, and you think you may have latitude. It's now time to think again. Those standards or those errors and omissions may not afford you a reward as you may have expected. Because everybody is deemed as being competent, you're being given the opportunity to put a conforming tender in or a conforming price. Contracts are now starting to stitch up these type of issues. The next thing is understand your own technical capabilities and the capabilities of others and the capabilities that are required to complete a job. So that's the back passage of the information that we need to address today. Now, I use those terms, the back passage, and if you can see the images into the back of my presentation here, you know, if we can't connect up a cable, we'll just tie a knot in it and forget about cable installation practices. We'll just throw it all on the floor. It eventually goes down the conduit. This all too is a common occurrence in my day-to-day work and in the work of other auditing consultants. So to minimize risk, we'll understand what your scope is. Understanding your scope as compared to your documentation is essential. The documentation, as I see doing peer review work, when it's coming from specification, people say that it might be 30% DNC design. It may be 50% DNC design. But unless you've come from an era where you've been involved in full detailed design, which we haven't seen for many, many years, it's hard to actually understand what that actual percentage is. But at the end of the day, you need to deliver, specify, or complete a design to make a fully fit for intended purposes installation. So If there is a deficit in the documentation or there's a deficit in your contract, make sure you clarify those points. Understand what your scope is. Identify where you're not doing work and make sure explicitly it's clear that you're not doing certain types of work. Because at the end of the day, when it comes back to the contractual side and it says you must comply with all relevant standards, then somebody who's going to judge the installation, judge your work, judge your documentation, judge your quality plan, as it's just been raised, this in itself could be favorable in your case, or maybe less favorable. Avoid assuming that the scope by verifying any anomalies. Recently, I had a installation. The contract said you must run Cat6A cabling. You must run it from the computer comms room out to all of the distal points throughout the installation. But the specification didn't say that you needed to have terminations on each end. Now, I suppose some people can look at it and go, well, it can't be a functioning system if it's not connected at both ends. But this, and I'll say young installer, decided that it never explicitly said that he had to have an installation connector at each end. So all he did was run the cables and then decided he'd wait until just before practical completion and then decide to put a variation in for all the connectors and all the testing associated with it. Should have suggested that didn't have a very favorable outcome, and it actually hurt him. And when he sat down with his builder, who he was contracted to, and we had some overwhelming heated conversations about contract and scope, he won the job on the fact that he hadn't included all of this and had a conforming job because he thought he'd be a little bit creative in his interpretation of the scope. But unfortunately, it didn't have a favorable outcome. So understand those anomalies, work through those points, make sure you cover everything off. And when you submit your contracts or your contract scopes or your quotes, identify what you're excluding, what you are including, and tell people you're going to be more expensive than others because you're going to do it right and you will meet all of the requirements of the standards. There's value and price in what you do. Don't let anyone discredit you for the abilities that you have, the years of experience that you have invested, and let people pay for that and do your job properly. Because unfortunately, the other side is that you'll have to do rework. Be aware of when the scope exceeds the requirements of the standards, or understand, does the scope require you to exceed those standards? People may be asking you to deploy standards or deploy work that meets requirements that you're not obligated to do. By all means, identify and say, yes, that might be in a draft spec, might be in a draft standard, but this is the obligation now. And clearly define those and have those conversations up front. If there's missing information, it doesn't lead to the variations, as I just said. But if you identify it early, highlight it, then it gives a better forum. Now, look, I understand some of you may be thinking, yeah, if I do that up front, I'll never get an opportunity. If I do that up front, they'll resend it out for retender to all of the guys that they're favorable with. Place your time, think about it, but don't think you can hold it back, because eventually it will come to the surface. And people are now starting to check these first gate items. And if you don't pass the first set of gates in inspections or audits, it unravels the project very, very quickly and takes away the shine of good work. So understanding our scope, other industry standards and codes. Murray talks about RS3 and the crossover now with electrical trades and AS3000 and so on and so forth. Equipment standards is another one, and AS3820 may not necessarily pertain to you guys in the comms world, but if you're doing quite a cross-pollination of work, these things can come up. But we need to start to understand how these impacts have and can have on the job that you're doing at hand. In addition, the mandatory requirements of the standard, you need to understand, but not limited to the following categories. We start to see this coming into contracts. You may see it in some of the contracts. Actually, a lot of people we talk to, they don't see it in contracts because they're so overwhelmed by winning the job that they don't look at these finer details. They sign it under what I would call duress, in my own opinion. They're overwhelmed that they've just been through 6 months of negotiation, making less than 2 points on it, but they really want the job to keep the company going, turning over cash, and they'll sign until something goes wrong. So be aware of this. Be aware of the influences, but not limited to. It leaves latitude, huge exposure, massive risk. Keep that in the back of your mind. Define your outcomes. Ring fence your exposure. The other thing that we see is understanding the contract in its full capacity. One of the things that I see, which is important here, is the contractor must not copy, modify, reverse engineer, or disassemble the whole or any part of a design for the goods specified. One of the things I want to share is the amount of non-compliant equipment, cable. It's terrible how much is out there. You see the sinking feeling when you say to somebody, can you produce me a compliance certificate for that cable? Did you know that that cable is not certified for the Australian market? Did you know that that cable doesn't have an insulation protection when it's in certain applications? Did you know that it can't carry a certain amount of voltage? If it does carry a certain amount of voltage, have you heard about all the other implications that come with it? So be sure that what you're given in a set of documents, in a specification, what you're buying from your wholesaler, because yes, they have an obligation, but they don't really care. Not until it goes, you send it back to them or you inform them of the problem, and then you're in a commercial stance or you're in the middle of a job. So I'll go on to talk about compliance a little bit further, but keep it in the back of your mind. Quite a high percentage of the jobs that we see, cable installation practices aren't compliant. You need to check compliance. You have an obligation. It is mandatory that you check before you install. Well, you can install, but it's likely that you may have to remove. One of the things that I'm starting to see in contracts at the moment is how other parties, third parties to you, can influence or impact on you. And some of the contract clauses that I'm seeing are what I've stated here. I'll just skim these because I want to keep this nice, short and brief and open the floor for conversation. But this line I pulled out of a contract that I was reviewing. I was actually starting the processes of contract litigation as a special witness to a major contractor. And they were astonished that they had no recourse in this. But what sickened me when I read this, and I was on the good side of this, but through empathy, I was starting to think I'd hate to be on the receiving end of this. A contractor hereby irrevocably and unconditionally assigns and transfers all right, title, and interest, including property and intellectual property in the design deliverables to the principal, immediately on the creation of such things, free of any encumbrances or any third-party rights. So you've picked up a job. You thought you'll be creative. You've found new technology. You've gone and done an extra design. You've redesigned a D&C contract set of drawings that was 60% done. All of a sudden, you find that you're in a trouble under a termination clause. You're no longer on the project. You may run into some difficulties contractually. You may be delayed. All of a sudden, everything you've done, you have no rights to. You have to hand it over. You're vulnerable now. You've got no leverage. You can't maintain that contract. These are the sorts of things I would like to provoke in your thought process and how it can impact on you. The next one, the contractor must do all things at its cost, as it may be necessary to give effect to the assignment and transfer in clause XX, including executing required documents, procuring that an employee of a contractor or subcontractor or any other contributing person involved in the creation of the design or deliverables, including all authors, provide written, signed assignments and transfer of rights in design and deliverable. Where this comes into being a bit of a hairy one is that if you go and you buy a particular brand switch and the IP of that switch is under a non-disclosure agreement, it may be cutting edge, or you may have developed your own product. Under this clause here will bring that unstuck. And as you can see, it goes down tiers. It goes down to secondary and tertiary applications. And so in some cases, this clause is tied to financial payments at the end of every month. So what we've seen is that unless you can go and say, for example, brand X, you ask brand X for a written disclosure that you can use their IP on a job and they give you that authority, you may not get payment. Now, this is the first time I've seen these type of clauses. However, I don't think this will be the last, and I think they'll start to build. It's quite alarming where we're going in the industry. A couple more. I'll try not to bore too much and we'll keep moving forward. The contractor must, on request, where not prohibited by the terms of the conditions of all relevant contract. One of the things we found was that there was no definition for relevant contract. That could have been anything. And one of the things that you may find if you pick up a contract, if you're sitting in your office now and you've got a job that you're working on, one of the things that is at the top of it, it says that you will understand and you've seen the head contract. But how many builders or how many subcontractors or principal contractors have actually given you that head contract that now you are obligated to adhere to? Keep that in mind. Is that the relevant contract, or is that the contract that you're engaged to, or are you actually engaged? So keep those in mind. With the principle of an unpriced copy of the terms and conditions of any contract with a third party for the supply. So now you're being called on to provide that you've got a contract that you can use that third party information and the supply of those components for that design. Will not infringe the rights, including intellectual property and moral rights of any third party or any breach of any terms or conditions of the contract, and not enter into any contract with a third party for the supply of any component comprised in the design and deliverables without the permission of the principal in writing and their approval. So here you are, you've won your job at -2 points, keeping things moving, got this beautiful contract, you're signed it up, we'll get going, and all of a sudden you've got no autonomy at all to do it if things go bad. When it goes good, it's all good. But when it goes bad quickly. The contractor must not enter into any contract with a third party for the supply of any other component, design, or deliverables without the permission of the principal. So I'll come back to the registered engineer. If it's a DNC design and the existing design consultant has not been novated or has no connection to you, you may have to seek approval for you to take their design and then do the design, post that for the design and construct. If they don't give you the permission, then you may not have catered commercially for redesigning that current design, whether it was compliant or not. So consider this. So think about these things when you're tendering. Understand that you may have to have this as an exclusion so that you have the rights to come back and reserve the right to price this once you know the full exposure of these type of third-party influences. Review and understand your contract to the full capacity. The contractor must not copy. I've been through this. The contractor shall ensure compliance with all relevant standards. It may not be highlighted to the group there, but if you look at in S008, S009, there's quite a swag of cross-referencing to different standards and the obligations. I'd be very keen to get some feedback in the chat session as to how many people have picked up S008 and S009 recently, let's say in the last 2 weeks, and understand the cross-referencing that's required in any given job and maybe a current job that you've got. So understanding our contract exposure is review and understand the contract to its full capacity. Understand who you're indemnifying. This is another big issue that we're starting to find. Be aware of IP clauses and non-disclosure obligations under NDAs. You may have to sign an NDA, or you may have to seek approval, as I previously said. Understand the third-party influences on your contractual exposure, and understand what satisfies a claim, a delay or a variation. I touched on it a little bit earlier. So if we were to have a look at reviewing and understanding the contract in its full capacity, the contractor, some of the clauses that we see is that the contractor releases the principal from any claim or liability in respect to arising out of or in connection with any matters set out in the clause. So the principal gives you a set of documents. He says you will design to these documents. The documents are at 60%, they don't comply, they refer to a clause in a standard from 1954 or not current. It may refer to an act in another state or another country. It may refer to an EN standard, an IEC standard, which has no relevance to the current standards that we have. One thing you may or may not be aware of is that some standards, where there is a full adoption one-for-one from an IEC or an EN standard, and there is no Australian standard adopted for that, we are able to use those external standards. But where there is an Australian standard, the Australian standard takes precedent. What typically happens in those standards where we've adopted from international standards is that we may have local relevant adoptions, which is similar to what Murray was saying earlier. But the contractor must also comply with the directions of the principal's procedures and policies, including those relating to work health, safety, and security when performing any part of the services on the project site. So their design may also have you in a position where you may not be able to comply, but you are forced under the contract to comply with the principal's direction. If you don't follow the principal's direction, you may be in breach and you may be exposing yourself to termination. Now, you may think that this is pie in the sky, but I see it on a regular basis. And in a current case that I've got, it's actually happening based around these particular words. Now, there are other fostering words that support this clause, but this is the principal clause that extends into further troubles. I think this is an absolute fantastic one for contractors to get hooked up on. And I mean that with sarcasm. The principal shall have no liability in respect to any defect, including any safety defect, deficiency, non or underperformance, failure or breakdown of any goods, or in the respect of any damage to goods caused by the goods, or any defect, including a safety defect, deficiency, performance, or failure or breakdown of those goods. So essentially, if you go and buy a piece of equipment, you've got a nice active switch, it's cutting edge, everything's working well, you've run your cables, and at this point in time, you've actually put connectors on both ends, and you've tested it properly, and something fails, you may not have any recourse, but you're also left with the problem to resolve. You could be involved with consequential losses. You could have liquidated damages. You could have delays on site. It could have flow-on effect to third parties. Third parties could have flow-on effects to you. If the product is sourced internationally and you've got delay times, these things can all impact on you. And now we're ring fencing it with the fact that you've got no recourse whatsoever. I've got this clause in here, but I think it's pretty self-explanatory. I won't go into this and we'll skip forward. I've brought this clause back up again, but the contractor unilaterally indemnifies the principal against any claim, loss, expense, damage of any nature, including financial loss and legal losses and expenses to the indemnity basis, suffered or incurred by them arising out of the performance of the services provision, design and deliverables. So not only the deliverables on site, but the design in itself. So if you inherently bring forward a problem from the original design, you're actually going to bear this outright. You're going to wear these problems suffered or incurred by them arising out of performance of the services. Now, performance of the service. This is interesting. If you test and you install and you've done everything right, and all of a sudden the most distal outlet is not functioning as it's fit for its intended purpose, it will bring the whole installation into question. And then you may be held that you are not hitting the performance requirements of those cables. Yes, it may be gigabit. Yes, it may be only 100 megabits required. But if someone wants to have the capacity of gigabits and you can't get that, but it's only going to be their actual demand is 100 megabytes per second, you may be left with problems of being able to not hit performance. Performance is a very loose term, and it can be used as a very grey word in black and white text. The contractor must, before commencing the services, effect and maintain the following insurances on the term with the insurers approved by their principal. So now you're being dictated to that you must have an approved insurer to the principal's requirement, both public and third-party liability insurance to date of the contract until the contract has completed the services. Now that includes any extended defects. And when you get to your DLP period at the end of 12 months, don't think that is the end of this journey. If a defect is known and a defect is not known, but it can be established that a defect was there prior to the completion and acceptance, it's still deemed as a defect, and it can and possibly may be used to extend your DLP for another 12 months. That's in extreme cases, but sometimes there are extreme cases. I've seen this happen. And now you're being selected to carry your insurance to a term that the principal requires of you. Have you factored these things into your price when you're putting them together? As an industry, are we actually going to take on these risks? Are we actually going to carry the liability for a principal that we have no effect on? We give them unilaterally, irrevocably coverage. They take the profit. We wear the risk. And now they want us to make sure that we've got an insurance. If they say it's for 7 years, you've got to pay that premium for that project to cover that insurance and all of the other circles of sinister behavior that go with it. Consider these things. Consider them when you're putting your price together. Damage to real and personal property, including property of any third party. Geez, data center. Murray talked about 2 data cables, pulling down a data center twice. One that brings into the integrity of the data center, and I think that actually degrades its rating. Flow-on effects on that. McDonald's don't get orders. Domino's don't get their pizzas. People don't get their TAB on. Ladbrokes don't get the money. We've got big problems. Con losses and flow-on effects to that. Big issues. Consider this when we're working out in the industry. Consider this when you're putting your price together. Consider that an auditing consultant will find these clauses. They will explore these. And if it's to the commercial disadvantage of your business, other people's businesses, but certainly not to the people that they're representing, then they will take the path that will represent the best outcome for their client. Hopefully, with preparation, with these sort of crack initiators, we may be able to prevent this and protect your business long term. Be prepared, use your knowledge, push back, tell people that they've made a mistake. Oh, I tell you what, I've got a different idea. Can you approve this for me? Take those paths on, be proactive. Don't wait until the end of the project where it may hurt you. But the flow-on effect is if it causes injury, death to any person or property and so on and so forth, this could expose and not be worth the -2 points that you're taking on the project. Another good one, principal may at any time direct a variation by issuing a variation signed by the principal. How many times in the marketplace? Well, I got a variation order. You go back to look for it. He hasn't sent it through. You've been busy on the day. Your guys on site haven't covered over their paperwork. It's in the site diary. Got to go back through months of site diaries, finding what variations orders have been issued and had it been signed. I worked on a project for 3 years, 7,000 rooms. Ridiculous, something like 28,584 light fittings. We got down to it and the contractor never got a variation order for those fittings. So they didn't get paid. Well, they didn't get paid initially, but they'd spent a considerable amount of money getting paid because they didn't have a purchase order. The other thing was that they changed that particular product and they didn't seek an exemption. Yes, the product was a Me Too product, but it wasn't the brand that was specified. Now, had they put this brand that was specified in, it would have been a non-compliant product. However, that was irrelevant at the end of the day. But when they got to court, that was the only substantiating factor, that the product that was specified by a specifier, a very good specifier, who didn't check to see if the product was compliant, was the only loophole that allowed them to get paid. But had that product been compliant, they would have been out of pocket a considerable amount of cash and possibly would have spelt the end of their business on something so simple. Now, I pulled this clause 5.51 out of S008. Fit for purpose. The cabling product shall be selected and installed for its intended purpose. Fit for purpose, fit for its intended purpose is a big, big difference. Something to be aware of out in the marketplace. Everybody has a different interpretation of it. But if it's not fit for its intended purpose, you may not be able to close your project out and receive those payments in a timely manner. Keep these things in mind. Is this product that I'm getting, is it fit for its intended purpose? Cat 6A, is it Cat, whatever it might be? Do I need to have shielded? I saw those topics coming up before, guys and girls. Let's see if we can make sure we cover these things off. Because if we can find a loophole as an auditing consultant that is not really fit for its intended purpose, and then that flows onto that the installation is not fit for its intended purpose, then contractually, you might be back at square one. Time and delays, always a big thing on site. The contractor, this is a clause out of a contract I picked up just recently. The contractor must perform the services in a timely manner. So what is a timely manner? Very subjective. If you're starting to see clauses like this, you should define what is timely manner. Can you please define that for me? Give me a prescribed definition for this. And by the time stated in the contract or otherwise notified by the contractor. That should be principal contractor. So you need to know, what is my time frame? If I get notified, how long have I got to respond? If I don't respond, what recourse do I have? Keep these things in mind. The principal may at any time give written notice to the contractor to suspend or resume the performance of those services. So what happens in this case? So if they suspend you, say they suspend you on the 20th of any month, and you have to put your claim in on the 23rd, because that's typically how this rolls, right? And they're going to delay the project for 6 months. Who pays for that time? Who pays for the services that you've done up and from the 1st of the month to the 20th of the month? There's nothing in here that says that they need to obligate to pay those. They just put you on delay. They give you a written notice, and then what's your recourse? So be sure that you've got a clause that says at any point in time that you give me a written notice and you're going to suspend or resume for the time that we are suspended and to the time that we are to resume, that all our services and design process is paid for. And it will be agreed that this will be the rate, and you go to your scheduler rates. Bring it back to that, because I think this is a fantastic clause if I was an auditing consultant to say you're not entitled to a time delay. The other thing that we see on site is if you've got multiple faces open and for some reason you're being held up in one face, unless you're delayed in all faces, then you may not be subject to a delay notice or a variation for cost or time. If the contractor receives a notice under clause, the contractor is not entitled to adjust any of the contract value, fee, or other compensation, but unless notice of the suspension was given before of a breach of the contract by the contractor, the time for performing the services will be adjusted. So you guys should have enough experience, both from a consulting fraternity and the like. Now, say for example, if you are a consultant or a specifier and you are in the situation where you're working for a electrical contractor or comms contractor, and you are a subcontract to them, and the builder decides that he's going to issue a breach notice, and the breach is against your design, and it all flows downhill, because what they'll do is they'll issue the breach, then they will suspend the job, and then they'll suspend all avenues for you to do any recourse, and you'll sit there at your costs. Seen this happen? It may happen again. As I said, this is thought-provoking, not right or wrong. So Murray raised before, onto a lighter note, about standards. Maintaining adherence to prescribed standards is important. I'm currently in the process of litigating against a contractor who decided that his interpretation of a prescribed standard was the way to do a design, and then subsequently went out on site and was directing the contractor, the licensed contractor, to do the work, very much out of his capabilities. But however, he decided he would undertake that. At no point in time did anyone question this specifier come engineer. This engineer was qualified and said, as an engineer, you'll follow my direction and you'll do as I've requested of you. I've given you a notice and you'll do it. It just so happened that those directions were wrong. They weren't in line with the prescribed standard, but the contractor went and did them, right? Because he didn't want to be in breach. He didn't want to fall into the traps that we've just previously mentioned. But what he failed to do was step back, say, hey, you know what? You're not compliant with S008. You're not compliant with S009, or you're not compliant with any of the relevant standards. I must adhere to the prescribed standards. And under this, please tell me where I am in breach. And I believe that we aren't in breach, and we will not maintain the work until you verify your outcome, because this is not in line with the prescribed standards. So being prepared, understanding the standard, reading the standard, understanding how it impacts on you and what contractual obligations you have and what contractual avenues you have to push back. Be across them, be across the new ones, be across the old ones. Also be across amnesty periods. And sometimes amnesty periods may not give you the latitude, especially when you do a design and it runs across through an amnesty period. Avoid thinking that you've got latitude, or by not omitting a situation, you can use an amnesty period to fix an outcome retrospectively. Understand what your mutual standards are. Are they mandated? If they're not mandated, what is your obligation? Are there any updates to the reference of the standards? So is there a standard change once you get going? Maybe this is an opportunity for variation. Maybe this is where you're obligated because you irrevocably have no recourse. Maybe you are having to then update the cabling or the infrastructure or the requirements or segregation or flow-on effects throughout the project. How do you cover those costs? Is the design managed by your contract compliant to the current standard? I would hazard a guess that quite a high percentage, greater than 70% of the designs we see, are not compliant with the current standards. It is appalling. There are many reasons why we see it in the market. It is possible to take some time. Make an allowance if you're putting a price in to say, I'd like to get this peer reviewed, or Mr. Builder, or Mr. Client, or Mr. Principal, or Mrs. Principal. Have you had this design peer reviewed? Are you aware that this may not be compliant? My quote reflects the fact that this is non-compliant. To put a price in for the non-compliant is X, which we won't do. But my price right below it to do a compliant design is this. Show the differential, show that you've got knowledge, show that you're prepared, show that you know your standards, and show that you have value to what you're offering. I said it before about raising design issues. Does your contractual requirements allow you to meet the demands of the standards? Raise non-compliance to the standard early in the negotiation process. Disclose inefficiencies and possible solutions. Identify constructability solutions. An old engineer who was my senior engineer used to say you can put any lines on paper, but you can't build it in the workplace. You guys are experienced. Share that knowledge. Once again, be prepared. Say you can't run cables through I-beams. You can go around them, or we need to find a different path. Look at the design properly. Use your experience. Highlight deficiencies and constraints by designing in the installation with the current design, which is what I was just talking about. Some of the general notes down the side are new notes that we're starting to see off drawings that are coming through. And yes, I did seek third-party approval for that to put it in here. But some of these clauses are catch-all clauses. Now they may seem quite subdued at this point in time, but it's only when it gets picky at the end that we've got problems. Moving forward, understand your technical capabilities. Understand, can you possibly deliver the project outcomes? Be real with yourself. Have a look at, is this really possible? If I don't get a compliant design, or this design will be accepted on the fact that it's not compliant, I'm going to wear the noose around my neck. Do you need specialized licenses? Do you have them? If I don't have them, can I obtain them? Am I going to run out? Is my certificate of currency not going to be there? Is my test equipment calibrated? Is it still current? One of the things that we pick up on quite a lot is guys test. The equipment's not tested. It has been tested and calibrated, but it's out of calibration. So all of the installation requirements and the test results that you've just spent 4 or 5 days, and as Murray said, in some applications, if you go to this level of testing equipment and it takes you 3 days a day to do 3 outlets, and you've got to go back after you make a modification. Imagine if you get 3 months down the track and then you find that the calibration certificate that's been requested of you because you haven't put it in an O&M manual, and you find out that the auditing engineer or the auditor wants you to provide a certificate of compliance, and it can be proven at the time that you did the testing, the certificate of calibration is out. That's a considerable cost to go back. Devastating, and in some situations could bring a job undone. Should you look at subcontracting out to specialists, minimizing your risk, making sure that your contractual obligations upstream are met downstream, and diversifying your risk and getting somebody to do that work? Do you need a peer review partner? Have a look, somebody, an ally, even one of your tradie mates, or another business that you've got an alignment with. A small investment in the beginning saves a huge investment at the end under legal costs. A very important point here. Can you identify what is compliant or non-compliant products and accessories? Well, I've got a bit of a test and a slide coming up, and I would love some feedback on it when we get there. But my job day to day is to understand what's going on, what's happening in the import market. And some of the things that I'd like to share is that you must understand that if a supplier brings product into the market, it is the supplier, and not only the supplier, but the importer's responsibility to prove compliance to you, the end user who's going to install it, who's going to specify it. If you don't take this path of validating these problems, there is no statute of limitation on ensuring that your installation will cover you and your insurance will cover you if it's not. So take the time, request the information, ask for the certificates when you're putting your pricing together. Oh, yep, no problems. Love that cable, great price. Can you provide me the copy of the certificates? Okay, there are 2 types of certificates. I'm happy to share these in future correspondence, or if someone wants a bit of advice, feel free to ring me up and ask me. But there are private certificates, and then there are certified certificates. Big difference, need to check them. One says it's been tested in accordance with, and the other one says it's been tested to. Okay? Make sure you get the right one. Where can you go for further assistance? There are specialists in the market. There are people with experience. Reach out, do your research, make sure you're minimizing your risk, show your knowledge and be prepared. Understanding your technical capabilities again, check with the suppliers. I've talked about fitness for purpose. All right, hopefully you can both see this. I've redacted some of the details on these two certificates. I would love for somebody to comment, which certificate do you believe is compliant in this scenario? I'd love to see your questions. Is there a requirement to subcontract to specialists? Do you need a peer review? Where can I go for more further assistance? Keep those in your mind. Out of all of that, your risks are now minimized. You're now more well prepared. You're now using your knowledge. You're now reading your contract and understanding your exposure. And you're now going to push back. You're now going to request compliance certificates. And you're now going to test in accordance to the prescribed standards. That's all I've got to say today. I'm sorry if this has been boring. I've done my best. Normally it's an interactive process for me. I appreciate your time and look forward to working with some of you in the future. Thanks for your time.
Thanks very much for that, Peter. I certainly appreciate that guidance. It certainly wasn't boring. All too often, we just simply need to know what our risks are, but not just that, but also what to do with protecting ourselves from that, and certainly appreciate that. I do have a question that's come from Sean Williams. I'll just bring up his questions. Just bear with me a minute while I do this. Just wanted to get your thoughts on the requirements in contracts for subcontractors to hold professional liability insurance for design, especially in the case where the head contractor reserves the right to review and approve the design. Does that make sense in terms of what Sean was looking for?
Yeah, look, Sean, very good question. This is a bit of a grey area, but I will try and answer it the best I can. I will put an exemption in here. I am not a lawyer, not in contractual commercial law, but one of the things that is important here is that you may, as the primary contractor, so working for a principal contractor, you may also have to have professional indemnity insurance, or you may be having to rely upon the professional indemnity insurance of a subcontracted designer, qualified designer. Each contract may be a little bit different, but if you're taking on the design responsibility, what we tend to see in the marketplace is that you will have to have design responsibility, professional indemnity insurance, as well as back-to-back with the designer that you're engaging. Because what will happen contractually is that you'll both be mutually inclusive in any litigation. You may be sued, and then you may have to have a combined case to bring litigation to the designer that you are, but you'll receive the defect or the litigation notice in the first instance. Hopefully that answers the question.
Thanks very much for that, Peter. Just interestingly on this particular point, nobody wants to be sued, but unfortunately all of us go into contractual arrangements regardless of where we are in the supply chain. And the last thing we want to do is end up in court having to either defend or accuse a situation that we're not happy with. I did note something that you said, and this jumped out at me. A small investment at the beginning can save a huge investment during the contract when a disaster or a dispute occurs. That speaks volumes to me. And my takeout from this presentation is there are so many traps here. We don't want to be ignorant. We also don't want to be frozen and go, well, no sense doing the work. But it's about pushing back, as you mentioned. I did have a question for you, and you may or may not want to answer this, but you spent a lot of time in court with defending and accusing people in contractual disputes. Is there a common situation of who normally instigates these cases? Is it commonly the end user, the builder, the service provider, the contractor? Is there a common thread?
Yeah, look, one of the big things is that it depends on where the auditing gets done, Paul. But what we find is that the principal contractor is usually the one that imposes it, because they wear the damages initially and are ultimately responsible for the exposure. But it depends where the auditor comes in. Sometimes we'll come in at an end user's level, and the principal gets their back up straight away. Sometimes the principal auditor doesn't want to pay a contractor, and they'll get us involved. And as soon as we find that there is a problem with the contractor's installation, then that's the point of entry there. But I'd say primarily that it's the principal contractor to the contractor itself. One of the things that I've found as a really big risk in our industry is that sometimes there's a third party, like a special user group, that's actually going to occupy the building that the principal contractor is building and the subcontractor is putting the installation into. And what tends to happen is those user groups or those specialty groups that are going to take over the occupancy of the building at the end start to stipulate other requirements that far exceed what the requirements are of the standard and the scope of work. And what they tend to rely upon is draft specifications or fit for intended purposes clauses. And in some cases, Paul, they actually get up, and that can have massive flow-on effects to end users, to contractors, I mean, sorry.
Yeah, I understand. I think it's important that we understand the terminology in some of these contractual arrangements before we sign them. So I do take your point about reaching out to somebody for assistance.
Yeah, look, you know, if I've got 5 minutes just to tell you, I had to sit across a young from a young guy in court recently, and you know, he was a good tradesman, from what I understand, and he went out on his own and he started to pick up work, and he's now created, you know, more and more business opportunities. He's now got 10 guys working for him, and he's starting to pick up bigger work, and in a regressive market, he's becoming more competitive. And he's gone out and he's bought that nice Hilux, Paul, and he's put the jet ski on the back end of it, and he's got a nice home and a good family. And then all of a sudden, one of his installers decided that he made a mistake, and a fit for intended purpose clause come out, and that brought the whole installation into question, and the whole project unraveled. It causes stress to the young bloke, the owner of the business, the flow-on effects to third parties, his family, his children, the bank. Everyone's putting pressure on him. His guys were worried about their security of work. It's devastating when you sit across from somebody and they know that they're in the wrong. They try their best to say, I've done everything right, but they have not done simple tasks and have not identified where their risk is. So I felt so sad for him. But one of the things he took from it was this again, I'm going to take this away, and that was the essence of my passion for the industry. That a difficult situation, and being involved with you, Paul, and with BICSI, I want to make sure that people are prevented from being in difficult situations, both from design all the way through to execution of projects. And my advice to them is take your time, be valued for your experience, be prepared, use your knowledge, push back, and stick to the prescribed standards. Because when you're in court, it's all by prescribed standards. Experience rates for nothing.
That's very sage advice. Thanks very much for that, Peter. Let's thank Peter for his presentation. I think that was tremendous. A lot of food for thought for us there. Peter and I have been having lots of conversations as we sort of tried to craft out this presentation. One of the things that's coming out of this is perhaps the need for some workshopping. We're still exploring this, so it might be a case of we start looking at some workshopping for various members at various layers, whether it's at design phase or installation phase or whatever the case is, and just get the benefit of Peter's wisdom and his experience from effectively keeping people out of court. And that's really what we want to do, isn't it, Peter?
It definitely is, Paul. And, you know, given I've still got that box of Cat 5e, it sort of gives you a bit of a vintage as to how long I've been in the industry. I had a look this morning just to sort of see how many scars I had, and I look back and it's close to 35 years now. And if I can share some of that knowledge, I'd love to share it with some of the members. And just for the sake, I'm actually a member, and I really wish to contribute where I can.
Certainly appreciate it. Thank you very much for that, Peter. Well, folks, we've gone a bit over time. We do apologise for that, but I think for everyone, we've gained a great deal of valuable insight into some very topical issues, be it the trends within standards or whether in the contractual conditions. This is all about being more professional. This is about protecting ourselves to ensure that we deliver professional results for our clients, but also don't fall apart because of some tricky situation. So hopefully it's been helpful to everyone. We're going to maintain this program. We're going to do it on a monthly basis. It'll only be one presentation a month rather than two. This was sort of to launch it with some very big topics. Just to give you a bit of a heads up, we haven't got it scheduled as yet, but we're aiming for the end of April or early May. It may end up being early May, courtesy of all the public holidays. We've got a gentleman from the Department of Education, Victorian Department of Education, presenting on the Head Start program. He is a cluster director. I'm just waiting for a name, but we're going to be talking about initiatives to build the next generation of ICT professionals. So just to fill you in on that situation, we've been approached by the Victorian State Government for assistance in talking to the next collection of the kids effectively. What are we doing as industry to try and help them see us as a viable industry for them to want to invest their time and effort to develop a career? Now, we also ourselves in this industry know about this quite well. We've been involved with it for many, many years. The whole idea is to then start focusing on what we can do to reach out to this next generation. So we'll let you know the details of that. And just a final note for those of you who are credential holders, if you've registered, we'll take care of your CEC. We'll send that information off to BICSI Credentialing Department in the US. If you haven't registered and you've attended, you've perhaps found out about it through someone referring you to us, by all means, please let us know so we can capture that, and we'll send that information off to the US to make sure you get those 2 CECs, which is very, very important. So I thank you all for your time and attention for participating today. Thank you again to Murray and Peter for their very, very insightful presentations. And we bid you a farewell. Thank you very much for your time. Goodbye.
Thanks, guys.
Just a quick one, Murray. I think you're in control at the moment. Would you mind just turning off the recording?
No, I think I gave you control, Paul. Made you the host.
Okay, all right. Looks like I've got that. Thanks for that, Murray.
That's okay.
Okay, I'm now saving it to the cloud. All right, that sounds like it's all working well. Oh no, hang on. This is just recording from now. It said we're recording in session. Anyway, we'll see what happens with it.
I've got to stop recording here, so let me.
Yeah, if you wouldn't mind doing that.